welcome to the end game with Cataclysm. I'll be your host today, Maddie, and I'm just going to show you a little bit of how Cataclysm works. We've got a notebook set up here that kind of walks you through installing it, setting up your API keys, etc. But we're going to focus on actual use. First thing we're going to do is explore the global Cataclysm. In this situation, we're importing the consume function from Cataclysm and feeding it the globals dictionary. This means that now Cataclysm has taken over. And from there, we now have the ability to do all sorts of things. So I'm going to go ahead and run this so I can explain it while it's generating. But essentially, now that Cataclysm has full control over the built-ins, essentially any function that it comes across that doesn't already exist, it will make it exist. Using the power of modern code generation, it's going to create code that works in place of this function. So based on the function name, in this case, I said, hey, get phrases from Wikipedia, go from this page. I chose that name for no reason, I'm sure, and give it some other parameters to help filter it. This, may take a number of seconds when you're first using it, especially when OpenAI is overloaded like it is now. But essentially, it's going to generate that code for us and plug it into place as if it was always written already for you, and then continue execution. And it's finished. As you can see here, it returned a number of scary things like existential risks and existential catastrophe. Lots of scary words there, but that's not Cataclysm's fault. That's me as the programmer. I told it to do that. Now, those kind of things, once it's generated the code, it'll be able to reuse it whenever you want. But let's show a different example. In this example, we've defined some sort of a graph. We've said, hey, each of these edges take this amount of time to traverse. Regardless, it's just something we're delaying on the fly. But instead of Googling an answer to how we find the shortest path, we'll give it some hints or describe the function we're looking for and provide it the graph, provide it the arguments, and then magically in the Cataclysm, the problems are solved for you. There's no worry, there's no scariness, there's no unhappiness. And in theory, it should be generating the code for us. And from there, we should be able to leverage it without ever having to have figured out how to code it ourselves. We literally get the AI to do it for us. And as you can see, it came back and it noted that the shortest path is ACBD. Now, if we later call the same function with the same arguments, it's going to be very fast, right? Because it uses the cached code for it. You can just do it again and again. It only does the generation once for any set of method name and parameters and parameter types. In fact, you could even look at the code on disk. We'll just go ahead and look at the YAML file where it's contained, and you can see it implemented all that in a minute, which probably is better than a human could do, and it worked. And for those who were a little squeamish about having any undeclared function in the global namespace doing your bidding, instead you can hide it behind this Doom object. If you wanted, from Cataclysm you can import Doom and instead leverage Doom dot in front of any function name that you want to have generated for you. Now, in this case, we have a list of dictionaries here with various grades and, ages or whatnot. And we're passing it into this sort students by average grade. So in theory, Cataclysm understands, the Doom object here does, it understands that what is being passed to it, it's a list of dictionaries, and it's doing its best to use the information to figure out what you meant by this method. And then it's going to, in theory, return a list. It's already generated the code for that pretty fast. It's printed the top 3 college students, and now it's moving on to the next part where it's going to basically get the adult student list from a list of sorted students and then loop through those. And it uses context, it uses the arguments, uses the function name to try to create code that satisfies the requirements of what you're trying to do. In this case, hopefully it should show us Alice and Bob with maybe similar averages, and exclude Charlie and Charlie 2, such an imaginative name. Thankfully, the AI does not judge you with your testing code here, and hopefully in just a moment we'll have the answer. We get Alice with an average grade of 85 and Bob with an average grade of 85, and just to be sure you can tell it all works, let's just give Alice an 88 there, and we're going to make Charlie 73, and we'll run the code again. And very quickly it gets back and tells us, hey, we get Alice with a grade of 87.6, Bob, and now Charlie's in the mix, good old Charlie, because he's above adult. So it did that super fast because the code has already been generated and it's already local. I'll also note, I forgot to mention, we also have a doom.average that calculated the average, right? Very powerful stuff. Very scary stuff. We live in a whole new era, but it's exciting nonetheless. For those of you even more squeamish, what you can do is that you can leverage what we call doom.impending to instead see what would be generated or what was generated for the code for a doom call and let you print it out. Now, it's in a format that can be exec. It is a sort of thing to let you preview the code if you're a little worried about what the AI has in store for us. But I, for one, welcome our new AI overlords. As a little quick demonstration here, I can show you about the way the inspection works. Right here, we're giving a very vague function name to Cataclysm. We're saying doom.processIt. You're not going to avoid its eyes that easily and trick it, because Cataclysm looks at not only the function names, it looks at the parameters, the parameter types, the keyword arguments. It looks at comments and relative code around each line in the call stack, as well as the call stack itself and doc strings, etc., to figure out what it should be doing. It really is trying as hard as possible to generate code that's exactly what you would like given the situation that you're calling it. It doesn't have to be just the function name. As you'll see in the example here, these are the Celsius temperatures. That's what we had originally. And the new list is Fahrenheit temperatures that it converted just fine. Similarly, we can do something similar here where we've got doom dump confetti on standard out, whatever we mean by that. But it can get some hints here because for the keyword arguments, we've got emoji mode and high randomness, and it can use those to realize that you mean those to be features of that code and will generate code to fit your requirements. And as you can see here, it executed in dumped confetti on the command line with a mix of emoji confetti on standard out, and did the same thing without code. And you'll notice the first one took about a minute to generate, as well as 103 milliseconds for the second run. Couple of examples here. It can actually, for small applications, become the application. So in this case, I've got a very small app. I tell it, hey, this app gets the image file from the command line and saves it as a new file at half size. And this is all you need. It does the command line checking, it does the resizing, it does the file saving, and this is all the code you need to be able to do that. For the hangman example, I get it to essentially randomly select word from a hangman game, getting a complex word list. While the word hangman word is not guessed, I print the ASCII art, and this example will essentially just run through a game of hangman, and I didn't actually have to write the ASCII art. I didn't have to manage a word list. I'm just literally describing the order in which it goes. Technically, I could do a lot of those just via comments or doc strings, but it's fun to see how you might build entire programs leveraging Cataclysm to do pretty much all of the coding. At any rate, hope you like it. Embrace our new reality in the final days of software development. I'm excited to see where it goes. Thanks for joining me.